So there's a standard technique for handling expressions like this, and I'm gonna write it out completely. There are shorthands that you can do, that you can sort of invent for yourself. So what we do, if I want to do cosine of inverse sine of 2/3, is I'll say, all right, what about this angle, right? Inverse sine of 2/3 is an angle, and let's have theta represent that angle, inverse sine of 2/3, and is like a way of thinking of inverse sine is we're really saying, what is the angle theta whose sine is 2/3? So sines we know, like we know an angle whose sine is 1/2, we know an angle whose sine is square root 2/2, we know an angle whose sine is square root 3/2, but we don't know an angle whose sine is 2/3. That's why inverse sine of 2/3 remains unsimplified. But this expression we can simplify more by saying, well, I don't know what angle this is, but I do know what the cosine of that angle is if I think about it being in a right triangle. So if theta is equal to inverse sine of 2/3, one of the best things to really understand about inverse functions is that the meaning of that inverse sine function is it means that sine of theta is equal to 2/3. So I have an inverse function, I put it to the other side of the equation as a regular function, or vice versa. Of course, with inverse sine, there are special considerations about the restricted domain, but everything we're dealing with here is theta is between 0 and pi, so we're meeting all the restricted domains, and there's no challenges with that. So what we do is we write a triangle. We just draw a right triangle that represents this. So here's my theta down here. I could put the theta up here, but I'm put it down here so it just makes more sense. And then opposite over hypotenuse, so 2, 3. All right. Now I can easily figure out what the adjacent is, and then I can get what cosine of theta is. So the adjacent is going to be square root of 3 squared minus 2 squared, which is equal to square root of 5. So now know what the adjacent is. So now I can say that the cosine of this angle theta is adjacent over hypotenuse, so it's square root 5 over 3. And that theta is the inverse sine of 2/3, so now I know that the cosine of the inverse sine of 2/3 is equal to square root 5 over 3. So another reason why I wanted to hit these topics is because this is a standard technique for handling this type of expression that you want to be familiar with when you go into college. You don't have to be able to do it off the top of your head every time, but be aware that this is the process. If you see two trig functions, one's inverse, one's not, draw a triangle and work out what this expression should represent. All right, so now I have up here, I think I can fit this in over here. 9/2 times the inverse sine of 2/3 plus, okay, so I guess I'm going to write out 2 times 2/3 times square root 5 over 3. So basically, this analysis allows me to get this number, which I am putting there. All right. Then what? Well, we can simplify all this stuff. So then we have 9/2 inverse sine of 2/3 plus 2 square root 5 over 9. All right. Now that I've sort of gotten my... do I have the right denominator here? Yeah, okay. Yeah, okay, I see what I did. This is 4 square root 5 over 9. Oh, so I've dropped the 2. All right, I see what I did. All right, so I'm missing some numbers because I already distributed the 1/2 as y. So I have 2 sine of inverse sine here, so I have actually a 2 there. And everything else is right here, 2 times 2/3 times square root 5 over 3. Okay, so that's all good. And then this is actually 4 square root 5, right? Because 2 times 2 is 4. And then I still have the 2 here, so I'm sorry about dropping a couple of numbers there. Dropped a couple of numbers. And the reason that I did that is because I sort of had in mind that now that I have dealt with all the substitutions in here, let's throw that fraction back in there and get 9 times inverse sine of 2/3. This is just distributing the 1/2 back in, plus 2 square root 5. over 9. Yeah, so that's distributing the 1/2 back in there. And then, see, I've picked up this denominator of 9, and I got a 9 out here. So why don't I write that as 9 inverse sine of 2/3 plus 2 square root 5. All right, so that's just simplifying it. And this is how, for your homework, this is the degree to which I'd like you to simplify it. And then if we want to, we can look on a calculator that can do this sort of thing. And let's go back to our original integral, which was, we'll go all the way back to the beginning. So we're going to go menu, calculus, integral. We'll go to, this is where we started. Integral negative 2 to 2 of square root 9 minus x squared. So negative 2 to 2 of the square root of, can you see that okay? Yeah, I guess so. Square root of 9 minus x squared dx. Now, if I did this on a TI-84, I would get a numerical result, and I could compare it to that. And here we can just do that, and we get the exact same result. You can see that okay? Yeah, the exact same result that we got. All right, so you're going to have to do one of those for homework. So just follow through basically the same steps that I did, and I just changed a couple of numbers.